Hi, and welcome to this Lernard.com chapter on installing Jenkins. These chapters are designed to follow on logically from one another, with Terraform leading into Ansible and leading into Jenkins, but it's by no means compulsory that you've sat through the Terraform and Ansible sections. If you haven't, I may very occasionally suggest that you go back and reference something from them, but apart from that, it should be fine. Veterans of the previous chapter will remember how we build up a diagram piece by piece as the subject progresses, and this chapter is going to be no different. To start with, the diagram is going to be incredibly simple, containing as it does only our own laptop. If you're using a desktop, by the way, that's no problem. I'm not really on a laptop myself, but this is just being used to show that it's the box we're working on, not a remote server. This section is about installing Jenkins, but rather than choosing to install it on a server, like we certainly would do in the enterprise, I've chosen to demo it being installed on our virtual Ubuntu desktop locally. I've chosen to do this primarily to save the cost of having an always-on cloud server, and to avoid filling this course with the complexity of spinning up and spinning down too many servers. But if you feel like you'd like to run Jenkins on a VirtualBox server, or a cloud server, please feel free to do so. The process of install is exactly the same as long as you choose Ubuntu, and also it's more representative of what you'd find in industry. Along with installing Jenkins itself, we're also going to install some standard plugins to increase the functionality of the basic Jenkins install. Jenkins makes heavy use of plugins for all kinds of additional functionality you might need, and we'll be revisiting this in later sections in more detail, though for now we'll just be using the suggested ones in the standard installer. Being aware that Jenkins requires plugins for much of its functionality is a good thing to be aware of from day one though. Finally, in this section we'll also take a look at creating an admin user, the one that we'll use to log in for the rest of the chapter. Okay, let's jump straight into our Ubuntu VirtualBox VM here and get cracking. As this is the first section in the Jenkins chapter, I'd just like to mention for anyone that's come straight here that all the courses on Lernard.com are done on an Ubuntu desktop VM running on VirtualBox. I go into exactly how you can configure this and why you'd want to in the Installing Ubuntu VirtualBox chapter in the Basics section, so if you don't have your own one yet, I'd recommend quickly popping over and going through that now before you go any further. For the rest of us, let's start by opening a browser window and browsing to github.com. In my case, I've pre-made an empty repository called Jenkins in the Lernard account, but if you want to follow along creating the code, and I recommend that you do, you're going to need to create your own Jenkins repo in your own account. Details of how to do this can all be found in the Lernard section on Git, by the way, also in the Basics chapter. I'm going to copy the Jenkins repo address here, and you should copy yours. And now let's open a terminal, cd to the folder we keep the repos in, and clone this empty repository for us to store our code in. As always, you can get a complete copy of all the code we make in this chapter by visiting the Lernard GitHub page and looking for the Jenkins repo. It will be free for you to clone and fully populated with everything we make. Now we've made ourselves that empty repo and cloned it, we're pretty much done with it for this section, as we won't start creating code until the next section. This was just a preliminary step. Next, let's install Jenkins onto our box. As I mentioned, if you want to install Jenkins onto a remote server you have, either in VirtualBox or the cloud, feel free to switch to that now. The process will be exactly the same. First thing we're going to need to do is install Java 8. I'm going to be cut and pasting these commands in, as remembering them won't make us any better at DevOps. You might only install Jenkins once or even never in your job, other than when you're making test rigs, so it would be an unusual talent to know them all off by heart. With that in mind, an easy place to find them all would be by Googling install Jenkins on Ubuntu, but I've also included every command that we use here in the README of the Jenkins repository on Lernard, so you can cut and paste them exactly as they are there if you want. So, first, let's install Java 8 with the command sudo apt install openjdk 8jdk. Now that's done, we can check it's worked here with java-version. And you can see it's listing the version, so the install was successful. To install Jenkins, we first need to add the Jenkins package repo and the key to allow us to use it. So, wget the package repository key. Then we add the Jenkins repository to our list of sources. And now we run a sudo apt update to detect the newly available packages that new source will give us. And now we can install Jenkins with sudo apt update install Jenkins. If it looks like I'm going a bit quick here, Remember that I am just cut and pasting all these from the Lernard Jenkins repo, so you don't need to type them all in by hand unless you want to. Okay, great. Now Jenkins is installed, we want to start the service using systemctl start like this. And we also want to enable the service using systemctl enable. Enable just means it will start automatically every time our desktop boots. So if we reboot for some reason, or we turn our desktop off, Jenkins will still be running when we turn it back on. For those of you that did choose to do this on a separate server, we also want to open the firewall to the Jenkins default port. So we're going to write sudo ufw allow 8080, which opens port 8080 on the Ubuntu firewall. And then a sudo ufw status can show that this has been added correctly. And that's it. It's as simple as that. The last thing we need to do is a couple of pieces of config and to check out our new server. So let's head over to the browser and see if it's up and running by browsing to http://localhost:8080. If you can see this lock screen here, then you know your install was a success. Jenkins is giving us an initial default password here that we can find at the given location. So the first thing we need to do is copy this and go and get that password to unlock Jenkins with. Sudo cat, and then paste the link to display it. And now let's copy that password and enter it back into the browser. So I'll just paste that in here. And there we go. Now Jenkins is asking us if we'd like to install the recommended plugins or whether or not we'd like to pick plugins from a list. As I mentioned, Jenkins gets a lot of its functionality from plugins. If we select the suggested plugins here as a good starting point, you can see here the ones it's putting on there and get an immediate idea of the sort of functionality plugins provide. We've got Git integration, we've got some GitHub stuff, we've got a plugin called Pipeline that allows us to use code-defined pipelines that we'll be using a lot of later in this chapter, plus LDAP, Email, Gradle and Ant, which are both build systems, and a whole load of other stuff. I'll be going through how to add extra plugins as well when we need them during this chapter, but it's a good fact to absorb early on that much of the functionality we use in Jenkins over our careers will require the install of some kind of plugin or other. For those of you that sat through the Ansible chapter previously, you can think of plugins as Jenkins as being fairly similar to modules in Ansible, extending the features to do everything we want it to do. Now that Jenkins has finished its plugin-a-thon, it's asking us to create our admin user. Jenkins can be integrated with enterprise login systems like LDAP, and for anything other than small businesses, I'd expect there to be quite a number of logins, if not some kind of integration. But for this chapter, we can happily just make do with using the admin login all the time. So let's just put in whatever username and password we like here, and that'll do nicely. There we go, all done. Let's just go to the dashboard and take a look. As a DevOps engineer, this is a site you're going to become very familiar with in your career. Lots of companies have now released excellent build servers as competitors for Jenkins that have been around for a while and are fairly mature and fill different needs in the build space. But I would be amazed if you didn't work at least one job where they were using Jenkins, as for quite a while it has dominated the build server market. You'll also find it common in the DevOps hiring space to hear people say, we're using X, Y or Z build system, but as long as you know Jenkins, it's fine. Because Jenkins is accepted as the de facto standard, the parent on which most of the others are based in look and feel, at least to some extent. And if you know Jenkins inside out, it usually doesn't take more than a few weeks to convert that knowledge to any other build system, and companies recognise this. That all being said, for the moment, let's not dive any deeper into what the bits of this dashboard are, as I think the best way to learn that is for us to put together a full Jenkins pipeline, building some code and deploying it somewhere, and we'll get familiar with the features as we use them. With that in mind, the first thing we're going to need to do is find a web application a bit more complex than our usual index.html we've been using in the previous chapters. There's loads of different example projects on GitHub that we could feasibly use as a dummy to build and deploy, but it's going to be handy if we're all using exactly the same one, so I've created a simple React app that will fit the bill. Let's go back to our terminal and cd to the repos directory, and now I'm going to need to get the git clone address of the example app in Lernard by browsing to the Lernard GitHub page and finding example-web-app. As I'm logged in as Lernard, of course I can just click on it on the left here, but if you can't find it, just search for Lernard up in the top left search bar and you'll soon find the Lernard page and you'll be able to locate it from there. As usual, we'll copy the git clone link here. And now, back in the terminal, we can clone this app down onto our desktop. Again, if you aren't familiar with these Git terms, do check out the Git section of the Basics chapter where I go through them all in detail. Right, let's CD into that app here. And now I'm going to open up Visual Studio Code, and once it's loaded, browse to that newly downloaded folder and open it. You can see here there's all kinds of stuff in here. It's a whole lot more complex than an index.html. And one thing you can be sure of is that simply copying this into the web root of an Apache server is not going to make it serve the web page properly. If any of you are wondering, by the way, I made this using React by just typing in the command create React app, which will automatically spin you up a dummy one of these sites like I've got here. You definitely don't need to know that to do DevOps. And that's kind of how DevOps is sometimes. You just get given a load of code and you're expected to build it, but beyond that you don't need to understand how the code itself actually works. So it's a good idea to get used to that kind of thing. So anyway, it's enough for us to know that we need to do something to this code to make it go. But what? In this case, the build system we're going to use is called NPM, which is short for Node Package Manager. It's massive in the front-end development world and well worth learning. There are loads of different build systems available for different languages, such as Maven, NPM, Gradle, MS Build, Grunt. The list is endless. Take it from me though that they are all pretty similar, and they're all trying to achieve similar things. You needn't really worry about learning any of them in detail before you try and become a DevOps engineer. Just pick them up as you go and you'll be fine. Many's the evening the day before an interview I've spent an hour or two learning some unfamiliar build system, but I've literally never been asked about it in a technical test, and I've never had any problem with it when I've gone to a new job. Anyway, the build settings for NPM are defined in this file here called package.json. You might recognise this section here from our introduction, which defines which dependencies this code is going to need to function correctly. As we discussed, dependencies are pre-made blocks of functionality, not totally dissimilar from the plugins we just talked about for Jenkins, come to think of it. Those of you who've sat through this course from the start will by now be noticing all the similarities between different technologies we're looking at. Plugins, modules, dependencies, these are all just ways to bring in pre-made blocks of functionality. Below this dependency block we have scripts, which gives us some build commands to provide building, testing and running facilities, which I'll talk about more in a moment. What's important here isn't that you remember the specifics, although understanding npm package.json files is quite useful. What's important here is that you understand the general pattern, that there's a load of dependencies and build scripts defined somewhere in the code, and we need to act on them as part of building this code into a usable web app. I think it's going to be well worth doing a manual build of this to demo it, so we can see for ourselves all the steps involved. This is going to be the only time we do this manually, and after that we'll be getting Jenkins to automate it. But I think it's worth going through this just once, so that it's clear what steps we'll need to achieve on Jenkins. So, let's switch to the terminal and do just that. Firstly, we're going to need to install the npm build system, which we get by installing Node.js. To do this, I'm first going to type sudo apt install curl-y, as the Node install is most easily done by curling down an automatic install script from their site. Now curl is installed, I'm going to write curl-sl https://deb.nodesource.com/setup_10.x downwards pipe sudo -e bash. This is something I've just pulled from Google, but downloading scripts and then running them like this isn't something you should ever do unless you know what the script does first, by the way. So in this case, setup_10.x, as it could be doing literally anything to your system. I happen to know what this script is already though, and I know that it's safe and what I want to achieve. Adding the Node.js repo to our apt repositories list and then refreshing. Now that's done, we can install npm by typing sudo apt install node.js. OK, let's quickly check our Node version here. Good, nice and current. And now our npm version. Great. Now that's done, we need to install the dependencies required for the code to work, which is done simply by typing npm space install. npm will now go and read from that list in the package.json and install all the bits listed there to the version specified, and create a local folder called node_modules where all these bits go. You might well be thinking, why not just check that folder into Git and then we never need to install them again? But that wouldn't be great. For one thing, these things are a lot bigger than the code you're likely to have made. The folder would be enormous and it would unnecessarily increase the size of our Git repo. Secondly, we also wouldn't be able to easily update and manage the version of those packages if they were hard uploaded into our repo, and sometimes we'd need to upgrade a version for some security update or feature. There we go, now we've got all our dependencies. At this point, if we want to, we can run up the site in development mode to have a look at it with npm start. This isn't something we'd ever do during a build pipeline, it's just for development, but I can use it here just to demo to you what the site should look like when functioning correctly. There we go, and here's our wonderful test site. I can only apologise for how silly this looks, but at least it's distinctive, so we'll know if we've got it successfully building when we do this in Jenkins. I'm going to jump back to the terminal and close this development server then. And now let's build a copy of this site that can be served in Apache, which is what we really want to achieve, by using the command npm run build. This does all kinds of things like compressions and minification, and critically it outputs all of our files into the build directory once it's finished processing them. Now, if I switch back to VS Code, we can see that the build directory has been created and contains all sorts of stuff. The contents of this build directory can be copied to an Apache web root, and we'd expect it to be able to serve our site correctly if we did so. All we need Jenkins to do is perform the simple steps that we just did, and we'll be able to deploy our working web app. Right, that's it for this section. Hopefully you've managed to install yourself a working Jenkins server and also successfully demoed some of the npm functionality we'll be using throughout this chapter. In the next section, we're going to dive straight in and try and automate the things that we demoed manually in this chapter using the Jenkins GUI. Hopefully see you there.